Hello everyone. In this part, I like to tell you more about the Nakamichi ZX-7 schematic and how calibration mode works. So I started my research. So there are 3 parts, and like as you may see, this part right here. So it's Azimuth switch, which actually starts calibration. These 2 flip-flops made on logic elements, which switch between 400 Hz and 15 kHz modes, and in turn use these transistors to light a different set of LEDs, as we've seen. Okay, so the 3 LEDs is type 1, type 2, type 4 for 400 Hz, and type 1, type 2, type 4 for 15 kHz. And these 3 LEDs are its different tape types: SX, EX, and ZX. So this 3 works all the time. This 2 works only when calibration is work. Okay. So the main actor, this flip-flop trigger, it remembers the state that we are in calibration mode, or we are resetting it. Then this part here is a generator using these 2 circuits. It allows to tune 15 kHz and 400 Hz level. Right? And how it works? This 2 T1, T2 goes from the flip-flops for levels, 400 Hz to 15 kHz, and turn on generator by using this pin 12. Okay? And a necessary condition that pin 13 should have positive voltage as well, plus 5 volt. In this case, when these both are positive, mean 1 in digital form, this element opens, produce 1 here, and opens this element to make generator work and generating. At the same time, this transistor will be shut and will cut off power to this LED. So you see it, negative signal goes. And there's a couple things. When we are in a source mode, these LEDs would not work. So using these 2 transistors, it will shut the power for these LEDs, and they would not perform, and LEDs would not be lighting. When we switch to the tape mode, in this case, these elements will be working. Okay? Next, what was interesting here, this part is Azimuth logic. These 2 amplifiers, then like another 2 amplifiers with diodes, and then the signal goes to like flip-flop trigger and recording this data in the different time frames. It produces different widths of impulses on the output. That's how left or right will be lighting up. Okay. Third LED would light only when we will have both levels normalized of the same level. So you see it's actually connected to this circuit. So it gives impulses through these capacitors, and it's another capacitor here, make it smooth. And like when there is no impulses, it's this circuit will open transistor, and this red LED will be lighting. In all other cases, if here will be impulses, this transistor will be open and this capacitor would not work. But this part was not working, and as you've seen, so LED is not lighting, right? And it appears that the main cause to make this thing work is to have 400 Hz signal from the tape, which goes through these two diodes here, joins, and opens this transistor. Without that, this transistor is closed. This trigger would not work. It always will be in the reset state. And this LEDs would not be lighting. That was like the first discovery I made. Then I was looking into this circuit, why generator works. And like when we switch to tape, it stopped working in 1 second. So exactly this capacitor here was keeping this 1 second level, and it's more sophisticated. So here is a source, here is a tape. When we click source, here is a negative signal comes here, and using these diodes, I believe it gets to, I don't remember, I was looking, but it gets to this pin 13 and makes here a positive signal, opens flip-flop, generator works. When we switch to the tape, so tape negative, yeah, that's how it works. When we switch to source, source is negative, tape is positive. This positive goes through this diode, 349, and here further it goes to the pin 13 and charges capacitor, and generator starts working. Then when we switch back to the tape become negative, source positive. And there was nothing happen. And as soon as capacitor discharge, in 1 second, all calibration stop working. And as you've seen, it's additionally cuts off power for these LEDs. Our Azimuth logic would not work, and so on. So I was digging in further. Why? And when I was debugging, I remember the first minute or 2 minutes when DEC starts, it's possible to engage calibration. And I found that we still have positive voltage here, even if we cut off tape signal, and there would not be voltage to go through this diode. So there is no current. And I was looking, and it appears that pin 13 was the difference. When DEC works on pin 13, we have positive output, which keeps our element open and generators work. Right. However, when counter doesn't work, we have not positive signal here, and we always get a negative, and nothing works, as we've seen. I was digging further, and appears that the only thing which doesn't work, this signal from the counter, mean up. Okay? That was when signal comes here, up. It triggers to remember state on the input, D, and transfers it here to the output Q. And it's become opposite, negative to Q, okay? It flip-flops. So it's remember our state, which we get into the input D. And T is a threshold, which will remember this in this trigger. So, and that's when I was, in my previous video, you may see, when I touch this pin 11 with the oscilloscope probe, this impulse was enough to trigger and remember states, and all calibration further starts working. And this trigger signal comes from the counter. As counter dead, it don't produce this trigger signal, and nothing works. And that's the worst thing which happened with this DEC. I have read a couple more articles in the internet that people has this counter dead and were looking for the spare parts. And when one guy was trying to replicate logic using a microcontroller. So There are ways to fix it, but they're way too complicated and will cost a huge amount of money if you will not do it for yourself, right? So I hope I explain it. I hope you know how it's worked now. So let me know your thoughts. I spent 4 days digging in to understand what exactly doesn't work in this schematic, why our calibration logic doesn't work. I was looking through all these diodes, through all signals, from where they come in. So here are Azimuth switch. This reset button, it was not working like when calibration mode not locked properly. This reset button doesn't work. So this impulse here, which should go through this transistor on the reverse signal to the processor, it doesn't work. And it was puzzling me a lot. Only these two buttons, like 400 Hz, 15 kHz, were switching these two flip-flops, and this logic was working. But that's it. Believe me, even like these transistors didn't work because this transistor was not working properly. And we had a signal which comes from here. You see 12 volts. And we have a signal from this transistor, which comes here, which should be negative, to close this one and let this two works. It wasn't working, and it was a puzzle I was trying to solve for quite a long time. So let me know if it was interesting, if you gain any new knowledge. I have a proof. I can make a pulse to pin 11, and all calibration logic works just perfectly. I'm thinking if I can put capacitor and put pulse here from somewhere else, like from this on or off switch, just to see if this pulse will be enough. I'm not sure yet. Maybe I will try it tomorrow, but probably that's it. Thank you. I hope you enjoy it. See you soon, and bye-bye.